right here. Does it work?
Yes, that's much better. The echo is much.
Yes, we will have people stand right here if they're going to talk. That doesn't
Okay.
work. Okay.
There's a lot of echo in this room, which is unfortunate. But there we are. Okay. I got 9 o'clock. We're going to start. Good morning, afternoon, evening, everyone, wherever you are in the world. This is Media Over QUIC, session 1 at IETF 125. Thank you for being with us today. As always, this session is being recorded.
And I'm Magnus Westerlund.
I'm Martin Duke, your friendly mock chairs. This is the IETF Notewell. It covers the intellectual property implications of you being here, as well as outlining our code of conduct. If you are not familiar with the IETF Notewell, I encourage you to put those words into your favorite search engine and read up on all of those policies. Here's some resources for the meeting. We're still relatively early in the meeting week. Some of us are just beginning it today. You can read the slide as well as I can read it to you. Okay, we will be using Meetico for joining the queue, having a short show of hands. If you're in the room here and have not already joined using the Light client by scanning the QR codes that are on the mic stands out there, please do so we are aware that you're here and we get the correct size room in future MOQ meetings. So again, if you have not yet joined, please join using the QR code on the mic stands. Those of you who are remote, please remain muted until you are about to speak, but be aware there's about a 1 second latency in turning on your mic. So you probably want to be a little proactive about that. Also, if you are remote in Meetico, it generally pays to have headphones due to the echo cancellation properties of this tool. And as always, when you enter the queue, please state your name and affiliation. This is the agenda for today. We're due to some conflicts on Thursday with the CFRG. We're loading up security topics in today's meeting. Hopefully there's some security enthusiasts here to comment on what we're going to talk about. Would anyone like to bash today's agenda? Okay, this is Thursday's agenda. This is obviously mostly non-security related topics. Would anyone like to bash this agenda? Oh, interesting. It did not. Okay, I had another slide that did not seem to make it into the presentation, so let me just call it up and I'll read it to you. We have a number of upcoming dates. One moment. Let me see if I can find it. There it is. Okay. Oops. I'm trying to share screen. There we go. Okay, here we go. Sorry for the delay. These are just upcoming dates in the working group. We've achieved consensus on a number of virtual interim dates. Those are all Mondays except for 26 May. Due to the US Memorial Day holiday, we moved that to a Tuesday. All those meetings will be 90 minutes beginning at 16:30 UTC. Furthermore, we've confirmed the location of our next hybrid interim. It will be at Cloudflare's offices in central London. The first 2 days, that's a Tuesday and a Wednesday in June, will be interop, as is our norm. And then the following 2 days will be issue discussion. So that'll be running through a Friday. Thanks again to Cloudflare for donating their space for this event. All right. Anything else for the, oh, I also wanted to pitch that Alan Frindell, our illustrious editor, will be presenting at HTTP BIS this week about compression over MOQ, what we're calling MOQ pack. So if you're interested in that topic, you might want to find your way to HTTP BIS this week. Any other comments or questions for the chairs? Okay, in that case, we'll hand it over to Alan, who's going to talk about updates to the mock transport draft since last time.
So you can see me. And can you share my slides? I won't be able to drive up, and that's going to be weird because I'm looking up the confidence monitor. Okay, there we go. Can you guys hear me okay?
Yes.
Okay, fabulous. All right, we're going to just cover everything that's changed in the draft since draft 15, since last time we met in Montreal. Next slide. Okay, just so people have the timeline, we published draft 16 in early January, and that is our current interop target. We found that kind of doing every other draft is a more reasonable cadence for people to get caught up and go a little bit deeper each time, given some of the wire image churn. And then draft 17 was published at the draft deadline for this meeting. The presentation here kind of covers both together if you want to separate it out and find out which changed and which, or if you want to go write an interoperable implementation, you should probably check the changelog or just pin the draft 16. The next interop target is likely going to be a draft 18, approximately 8 weeks from now and 4 weeks prior to the next hybrid interim. Next slide. So this was a comment in the Slack after we published draft 17. This almost feels like a completely new protocol. We haven't changed a lot of the API or the semantics of the protocol, but some of the wire image is significantly different. So we've replaced what has existed since the beginning of MOQ, which was there used to be a single client initiated bidirectional control stream, and that has now been replaced by a pair of unidirectional streams that are used for setup. And setup is now a single message, not client and server setup. And go away is also on that unidirectional stream. And then all of the requests that you would make each go on their own bidirectional stream. And that led to the removal of 7 different control messages that we previously had, which are now replaced by quicker web transport control messages like fin and reset, stop sending, etc. The data transfer has not really changed much. It still uses unidirectional streams or datagrams. And we have our own variants now, which we've wanted for a while, mostly because we wanted a larger 1-byte range and we wanted to support the full set of 64-bit numbers. So that is like the headliner, and then we'll go through like some other changes that have happened. Next slide. Paint for the bike shed. We renamed some things if you're coming back to the draft and you want to know where it went. So what used to be called setup parameters are now called setup options. People felt that it was confusing that setup and messages had parameters and they behaved differently. And then what had been inconsistently referred to throughout the draft as extensions, object extensions, and object extension headers has now been, those are now called properties, and they can be set on a track or on an object. And there's also a new recommendation for sort of canonically safely encoding some sort of binary track name. And there's an example from the draft is there, which there are other ways we could have done it. That's how it's done in the draft. Next slide. Track properties and message parameters. So in the last couple of drafts, we've tried to separate these two concepts out and make them crisp. So publishers can attach key and value metadata to a track, and that goes in publish, subscribe, okay, or fetch. So whenever the publisher is sending you a track, these track properties are associated with the track. And those are end to end. They go everywhere the track goes. Message parameters, on the other hand, are, I say hop by hop. I know some people didn't love that term, but the idea is that like those are really scoped to the endpoint you're talking to. Of course, if you're a relay, you might look at the parameters you got and then make a similar upstream request if you want to, but they are not guaranteed to traverse hops in that way. Message parameters are also now TV encoded instead of TLV, which makes them mandatory to understand. You have to, if you want something new, you have to negotiate it, because if you get a code point that you don't know, you'll have no idea how big it is. You cannot skip over it. Okay, next slide. Some changes in the control plane. We took what was subscribe update and we renamed it request update, and you can update all kinds of requests. And one of the main use cases there is being able to refresh your authentication token on an existing request. There was this expires concept in the draft that was very vaguely defined before, and we've crisped it up to explain like what that means and how you can refresh it potentially. We crisped up some of the language in joining fetch, and so now, for example, if you have paused a track by setting it to forward 0, and then you later reset it to forward 1, and you would like, and that happens in the middle of a group, and you would like to go back to the beginning of whatever group that happened in, that's now possible by issuing a joining fetch, so you can do it multiple times in the same track. Subscribe namespace has been completely rewritten, so there's a sort of a discovery mode, which tells you about available namespaces, and those come in the bidirectional response stream. And then it also can solicit publish messages, which come on their own bidirectional control streams in draft 17. And you can sort of say, when you subscribe, you can want just the namespace piece or the publish pieces or both. Okay, next slide. Data plane. We now allow you to mix and match streams and datagrams in a single track. Before we said like you're either a stream track or you're a datagram track, but now you can have, for example, base layers included using streams and then like datagram enhancement objects in the same track. It's fine. When you fetch something, there's now a way for the publisher to say, you asked for 0 to 10 and there's a gap in the middle and I have no way of filling it. So I'm just going to skip over it and tell you that I can't, and you'll get what I have, which we think is useful. And there's some other issues that are around that we'll talk about on Thursday. And there was a lot of weirdness in the object status enumeration that we have fixed up. So you can know object status is no longer like a true object, like you can't set properties on it. If it's not a normal object, it's really just a way of communicating where some of the boundaries are. So we removed the ability to send like object status does not exist on the wire. That just isn't something you ever need to do. And we've explained how end of group and end of track like work more crisply in terms of how you would use that to populate where the gaps are in your cache, or for a subscriber to use that. Next slide. Grease. This has been a to-do for a long time, and now that we have like figured out our extensibility story, we know what we need to grease, and so we have greased it. So everything that we think that you're allowed to send unnegotiated values for, there are now grease code points, which include setup options, properties, all the error codes, and the type of an authentication token. If you want to send a value in a field, then you have to negotiate that.
Alan,
Is there a question?
can you try to take it half step forward as to if it change how you sound? Because you're still being a little bit garbled. Yeah, try there.
Oh, I got too far back. Okay, I'm sorry. Is it better here?
Yes.
Should I speak more slowly?
No, it's fine. Yes, it sounds better here.
Okay, I'll stand closer. I mean, I think my mic is 2 inches.
And the mic's on the Chromebook.
Well, no, you don't know which one it's using.
We're not sure. Is it, maybe this is better?
I logged in this morning and it's doing something, and David set it up yesterday and he did something.
Okay, just leave it. I think now all the mics are close, hopefully.
Only one was on, so.
Okay, everyone got it? We greased stuff. People should start, that's in 17. So once 18 rolls around, people should start sending grease and breaking people that don't understand. Next slide. I heard you like Delta encoding. So we have Delta encoded pretty much everything that we can in the protocol. So when you send options, when you send properties, when you send ranges that have starts and ends, everything there is now Delta encoded. Motivation was both it being slightly smaller on the wire, but it also makes it very easy to do duplicate detection for things that allow duplicates or don't allow duplicates. They sort of have to be stacked together. Looking through the document, there's like only one, like I see that in fetch responses, there are like group IDs and object IDs that are not Delta encoded. And I would say that those days look numbered. And then I think we'll be out of things to Delta encode. So that's probably coming. Next slide. Errors, we added a bunch. So we added a retry after field to request error that is semantically mirrored after similar HTTP header, and a bunch of new error codes that express important failure conditions. And Go Away now has a timeout hint that you can use if you want to give the peer an idea of how long they have to get gone. Next slide. Rendezvous. So this is something that has been asked for a while, and we finally got it in there, which is that if a subscriber can express to a relay that it's willing to wait a little while for a publisher, that if there is not one there. So I subscribe at the relay for a particular track, and the relay is like, I have no publishers for that track. Some implementations would just immediately fail that. Others would sort of let you hang around. Now the subscriber says, like, I would like to wait up to this long for publisher to materialize. And it honors the French heritage of MOQ. Next slide. Okay, that was like all the updates in 15 or 16 and 17. So just a heads up. So we made a change for how we're managing issues for PRs that are still in development. So there's three fairly big pieces that are currently expressed in either PRs or separate drafts, and they're kind of in a rapid iteration phase. And none of these have merged into mock transport yet. We decided that we're going to track the issues with each of those proposals in the author's repo. And we found that tracking it on the PR, you would leave threads, the PR would get updated, GitHub would completely erase the thread or hide it. And we were just having a very hard time like tracking it and not losing things. And we don't really, the editors are trying very hard to drive the mock transport issue count down. And so having issues tracked in our repo for things that don't necessarily have clear consensus to merge in yet, didn't feel right either. So here's where the repos are. If you want to get engaged with those, you can obviously comment on the PR also. But if you have like a more substantive something that needs a lot of back and forth discussion, we prefer we have the discussion over there. Next slide. Okay, it's a little small for me to read here, but I'm going to see our current issue status. If you can see in that upper right corner screenshot, we are now down to a double-digit issue count. If I'm correct, we crossed over 100 in the wrong direction about a year ago, and we peaked at 156 or 157. So we've been working really hard since Montreal. The numbers, the green numbers here show the diff since Montreal. So we're at, and there's a small, the total doesn't quite sync because things were changing over the weekend when I was writing slides. But we've net closed 26 issues since Montreal. The biggest, so of the roughly 100 that we have left, there is, something like a quarter of them have a PR that will close them right now. So, people go review them. There is another third of them which are editorial, and I will say, we don't think it's a great idea to just go and make a bunch of editorial changes because it makes the diff harder to read. So we'll probably be strategic about which ones we fix and when. But it will not take very long to close that. Particularly for those who don't know, the editor team is now, at least I am quite AI assisted in producing PRs and can crank them out quite fast. So our list of things that need discussion is getting kind of small outside of our big rocks, which is a good thing. There are some people who have some not transport issues open. You might, if you opened this GitHub repo right now and looked for the issues that are marked blocked, you might find one assigned to you. to close because we don't, if it's not transport, there's probably a better place to track this now. There didn't used to be 2 years ago. So, and even the parked issue count, if you go and look through what's parked, a lot of it is sort of things we're like, do we need this? Do we not need this? You know, kind of open questions like that. And things like we need to renumber things, some to-dos to redo the security write some more security considerations, et cetera. So even that does not look like a scary list to me. So I'm still operating under a dream is that we will get this issue count to 0 post 126, which is in about 5 months, which means we're going to net close about 4 issues a week. So if you have been dismayed by the slow pace of MOQ in the last 4 years, now is your time to shine. So I think that's it. Next slide. I don't think I have any more slides.
Just one.
You'll have to enter the queue and then get close to this thing.
But I'm
not. There we go.
But Colin's over there.
Oh, actually,
The video is still on the other way.
David, do you know how to?
Oh, did you not put it there? All right, come on this side
Just
for now.
Colin, just in front of the thing.
And then I'll futz with the settings while you're doing
I
that.
couldn't figure out. That's why I was like, I don't know.
So it's actually goes back one more slide behind this one. We were talking about putting those in the other repos. I have a slight concern that those repos aren't archived in any way or logged from an IPR point of view. And those are all topics that are likely to have a ton of IPR. So I'd like to be doing those in a way we have that. I wonder if we could just tag them in a way that you clearly did not include them in your bug count.
Okay, so I know less about this topic about how IPR management and Git repo management is there someone who can speak authoritatively about it?
We don't have to resolve it right now. I just think it's an issue we should dig into. That's the only thing.
Happy to take other suggestions. This was just in the last week or two that I needed some way to track for filters in particular, needed a place where we could have long threaded discussions that weren't getting sneaked over each other.
Yeah, Alan, I think if we're going to, well, we are moving down this road, and I think if it's going to be an extended period of time before things are brought into the MOQ draft, I think we just need to adopt those drafts with the idea that we might eventually merge it into MOQ so that it's brought into the MOQ repo.
So, I mean, that would be easier if those features were, rewind is expressed as a draft. And, I don't know that it's we talked about it a ton in Boulder. I don't know that people have reviewed it in detail. We can have an adoption call for it. Filters and switch are still expressed as PRs against MOQ. So I don't know, are you suggesting that we just go ahead and merge them in a rough state, that we maintain them on a branch, or that we ask the authors to convert to a draft form that can be adopted and managed separately?
I'm not suggesting anything related to the existing PRs against MOQ. I mean, there's no IPR issue there. That's in the working group repo. That's not an issue. But the issue that Colin brought up, there are these individual drafts floating around that are at least intended to eventually merge into MOQ. Maybe they'll become extensions. That's something for the group to decide later. But if they run for a long time outside the MOQ draft, then we should, assuming there's consensus, we should adopt them so that they are brought into the working group repo.
Martin, what you just said was not what I understood from Alan. I read the slide as, let's take filters, for example, that is not in the IETF repo. It is in Mozambique's repo.
Oh, yes, you're making an excellent, yes, I'm sorry, pardon me. I'm not even familiar with for the PRs that are now also repos. I've not even honestly looked at the GitHub food that's involved there. But this is something we need to figure out.
Okay, I would take an action item with the chairs to figure this out and make sure that IPR is correctly resolved. That sounds like an important thing that we should do. Please take further minutes. Yeah, right.
Rowan?
So could you go back to slide 5?
I can't move to slide 5, but maybe the chairs can.
Okay.
There you go.
Hi. Yeah, so I wanted to understand, so it sounds like with this change that a relay, you could negotiate with your first hop relay, but then that relay, it could remove things, but it really couldn't add things unless it already had some kind of pre-configured knowledge of what the next what the next hop could
When
do.
you say things, are you referring to properties of the track that the publisher is sending, or are you referring to parameters in a message that are
Parameters
back
of
to
the message that
Okay.
are going to the next hop.
Yeah, so, I mean, relays generally are like aggregation points.
Yep.
So,
Are you on mic?
what's that?
Are you on mic?
Am I on a mic?
I think so. They're picking you up. You're not
Oh, yeah,
speaking
get a bit
mic.
closer to the mic on there. I'll refresh after this presentation.
Okay, the point is that like, particularly when you think about subscribe, your subscribe may only go to one hop because it may have, that relay may already be subscribed upstream. So you can't make any assumption that your parameters are going anywhere further than the first hop. And so if you want to subscribe with some super cool like thing, you're like, that is only applying to your local, the local relay that you're talking to. If you're publishing, you can set properties and those will go wherever your track goes. And there's a separate PR that's open that talks about possibly creating a mandatory to understand type of property, which is if you're a relay and you get something, you would be able to identify that you don't understand it and you would just blow up if you got one because you don't, for some reason, it's not safe to deliver that way. Was that clear?
Thank you.
I feel like it was, but
That helps.
okay. I can't see the queue very well if there's any more people in the queue. No.
Okay, the queue is clear. I think we're ready to move on to the next topic unless someone raises their hand immediately.
Okay.
If I may, very briefly, we're gonna refresh the thing here so we can change the camera. We'll be back in 3 seconds.
Okay. Well, you didn't wait for the reply. While we're sitting here waiting, if you arrived late, please scan the QR code on the mic stands to join with the light client so that we know that you are here for multiple reasons. It would be much appreciated if you could do so. Your way of signing the blue sheets is just to join with the light client. And it's back.
And we're back.
All right, excellent. Next up is Alan. In case you missed Alan for the past 2 minutes, he's back to talk about MOQ URLs.
Thank you to read the slides. Thank you.
Ooh, that's a better camera.
Is the audio clear from here?
Yes, actually.
Okay, that's good. I'm talking about the MOQ URL, and I've got a slide in here from Will. I don't know if Will wants to be close to a mic in case he wants to talk to his slide when we get to there. Okay, next slide. Okay, so in the Boulder interim, we were talking about URLs, and we designed this new thing on the fly, which is in PR 1486. So if something is a MOQ, and this is about how does the client know what transport to connect with? And so if you say MOQ, that means the client, it should send an H3 ALPN and all of the MOQ ALPNs that it supports. Now, of course, if it doesn't support web transport, it doesn't put H3. If it doesn't support native QUIC, it doesn't put the other ones. But if it supports both, it puts them all, and it can put it in whatever preference order it wants. And the server will, if the server selects one of the MOQ TNN ones, that means you got native QUIC, and it tells you immediately what version you're speaking. If the server selected H3, that means that it wants to do you're not done yet. You need to try again by sending a Web Transport Connect request, and you use WT available protocols using the same list of tokens you had in your ALPN, but with H3 removed. Let me pause there and see if that's like sort of, I don't know, call it like the universal client. Like that's how it's supposed to work. We also thought it would be nice to say, well, what if you want to tell somebody to only try QUIC? So we added this like plus Q and plus WT syntax in the scheme. And so if you got a MOQ plus Q, that means don't even try H3. And if you got one plus WT, it means don't try the native QUIC ones. Next slide. Okay, then we also got some feedback on the PR, or on the scheme. And one of them, the feedback was that like, you really shouldn't be messing around with schemes like that for things that represent the same resource. And MOQ foo.com/bar and MOQ plus Q foo.com/bar actually are the same resource. And URIs are specified such that when you're trying to determine something, you compare exactly on the scheme. And so we're sort of fighting the system. But then I also took that a step back to think about it, and like, what exactly is the point of trying to why were we trying to put transport selection into the URL in the first place? And so I try to make this table, which is like, what does the client actually support? And what does the server actually support? So in almost every box in this table, nothing changes with having those URLs, right? If you were a QUIC only client and somebody sent you a MOQ plus WT URL, you're going to fail. With the scheme we cooked up in that PR, you would fail immediately. And if we removed it and you sent a generic MOQ URL, you would fail when it got to the server and there was no ALPN match. So it's going to fail either way. And the same for the opposite, where the red X's are, right? If the client and the server just don't speak the same transport protocol, it's not going to work no matter what you do. And if they only both speak the same protocol, it's also not going to change anything. It only really matters when they both support both, in which case the client expresses its preference in the ALPN list and the server's preference is going to win. And so the question is there any point where you would want to be telling clients that support both to restrict the set they're connecting with? And I sort of can't come up with a reason why. So to me, that's like, let's keep the good, which was like the generic MOQ URL, and toss the plus WT and plus Q. So let me just pause there and take feedback on that approach, because it's different than what we said in the room in Boulder, and I don't want to change it for people. I can't, there's someone in the queue, but it's very tiny.
Benjamin.
Hi, Ben Schwartz. Talk to me about QMUX.
QMUX is not, we'll see who wins the race here, but that may be their problem, not ours. But in a way, I think that, I don't know, talk to me about HTTP2. If, that racing QUIC and TCP is already a problem, and I don't think MOQ is going to try to solve that problem. Or are you suggesting that we should vend URLs that are like, this MOQ-T thing can only be accessed via TCP?
I'm not suggesting anything. I'm just pointing out that, yeah, we have more than two protocols in play here. We arguably, I guess, have four transports below substrates, essentially below MOQ. So this table gets to be a lot bigger, and the situation gets a lot hairier.
Yeah, I mean, for that matter, even web transport is hiding web transport over H2, which is also a completely viable way to speak MOQ-T. But we sort of assume that that's you already figured that out for HTTP. So unless somebody has really great ideas about how we can improve that system, I say we just use the same one. Next,
Ted.
maybe it's Ted. I can't tell. The picture is very small.
No.
We cannot hear you in this room.
They couldn't hear me in the room either. This wasn't
Okay.
turned on. Ted Hardy speaking. I much prefer the version without the plus Q and plus WT. I think it's cleaner, and I think you're persuasive with your table. There are a couple of people in the chat who are talking about yet more potential substrates like QMUX or something else, and I think that actually makes it even more important for us to ask the question of like, what resources are we addressing, rather than, what's the set of protocol steps to reach the resource? Because I think that's where, when you're talking to the client, you ultimately want to say, this is the resource you're trying to get to, and the mechanisms by which you're going to attempt to reach it are determined by the protocol, not by what you see in the URI string. So I think from my perspective, the URI string is much cleaner the way you have it now.
Yeah, thank you. And you can still select an individual transport by running it on a different port or with a different name or IP. Next.
Yeah. So, this is great fun. I can't see myself. I can't see what's going on. Sure. Yeah. Anyway, I think we're rapidly converging on this idea that we'll be removing the plus variants. Ben did ask about QMUX. I think it's going to be a problem that QMUX has to solve, not us, because QMUX will need to be able to say, when you negotiate TLS over TCP and you're going to be doing QMUX, QMUX isn't the thing that you're negotiating in that case. You're negotiating the thing that's sitting above the QMUX, and it'll need to be able to be identifiable somewhat. It probably needs to be distinct from the web transport version. So you've got H3, and then you'll have a MOQ-T over QMUX or something like that. That'll need its own ALPN in that case, distinct from that. Or it could just be MOQ-T in that case, because that works.
I imagine you do the same thing.
do the
H2,
same
Mach
thing.
T16, Mach T15. And Mach T16 says, if you
Right.
negotiate this, that's QMUX version 0.0.
Right.
And Mach
Yeah,
T18 is QMUX version, which is how we did it for QUIC. There is an issue open in the QMUX repo for that, and there are people with opinions because there are Mach T implementations that run over QMUX 0.0 right now. So, we're doing crazy things. So I think we'll talk about it in QUIC, whichever day that is, tomorrow.
Yeah. So there's been a long sort of question about this. David's doing a great job here. A long sort of question about whether or not a URI scheme identifies an abstract thing in the sense that this MOQ-T thing would be, or HTTP has decided, or whether it identifies the sort of means by which you obtain the resource. And I think we're sort of gravitating generally in the ecosystem toward this sort of abstract notion for the URI, and a much more concrete notion for the ALPNs. But again, there's some question about that as well, as to whether there's some level of abstraction in the ALPNs as to whether they refer to the entire stack. I mean, obviously in your web transport example that you had previously, the WT available protocols will probably use the ALPN tokens that match what you're using over QUIC. So it's not a concrete instantiation of MOQ-T with the stack underneath it. So we're in this sort of weird liminal space in terms of what those labels mean. But I think ultimately the right thing will happen, and you'll use a combination of the label and the context in which you find that label to determine exactly what you're going to do. But you'll have to be a little bit careful in these cases when you're managing multiple version SKUs, as QMUX goes through different versions of drafts, as MOQ goes through different versions of drafts. Syncing them up was probably the only way to deal with that in the short term. And longer term, yeah, good luck.
Yeah, no, well, I don't think we're just the first. We're not, or maybe we're not even the first, but other people have that. Next.
Yeah, Martin Duke, Google as an individual. Yeah, well, I think you're getting strong feedback to get rid of the plus. So +1 to that. There's if I understand correctly, like the way this works is as a client, then I would advert. So there's 2 layers of protocol negotiation because of if you're using web transport. So at the QUIC layer, the ALPNs are MOQ-T 16 or whatever, and then
No, for web transport, it's H2 or H3 are the ALPNs.
Pardon me, H3. Yeah, pardon me. So you have H3 and web trans. I'm sorry, web H3 and MOQ-T. And then assuming the server picks H3, then you have the further web trans negotiation, which can then lead to MOQ-T. I guess the only time you have a problem there is if the server picks H3 not knowing exactly what you're doing, and then you kind of end up in a spot where you can't actually negotiate MOQ.
You mean like it's a web server, but not a web transport server, but it was also a MOQ-T server?
Yeah, I mean, I'm thinking this out loud at the mic. I mean, I guess you could. Well, I mean, like, I mean, I guess if you, I mean, if you have a web server, I mean, I guess you might not implement web transport, but also be MOQ-T. I don't know. I mean, I guess that's the education is bad here, but I think I can live with it personally.
Okay.
Okay.
I think that's kind of a weird case.
Yeah, I agree.
Okay. I do see the queue getting longer. There is another thing about URLs I want to talk to. So if the chair's gonna let me know how we're doing on time. But if everyone's getting the mic to say, don't do plus, then you don't need to say that. I think we got
okay. We still have 7 minutes, so I'm not going to cut the queue quite yet. But
okay, but I have another non-transport related topic in this deck, which is about fragments.
Okay. All right, then let's move along.
Colin,
Okay.
Thank you for providing services. But, you know, +1 to minusing the plus from the scheme. But the thing that I think is important is I think we have a very simple model for how we do this, which is every layer, what we do at any given layer is purely say what the next protocol is, okay? And that's how we do it in web transport. So in web transport, we just say, you know, H3 is the next protocol. And then inside of the web transport protocol, we negotiate the what's the next protocol, which is this. And we should do exactly the same thing with QMUX. I think that that model is going to work really well for us for all of these variants. So what you will say is you will say QMUX 0 is the next thing. You don't mention MOQ at all, right? And then inside of QMUX, you say the next protocol is MOQ 18 or whatever it is.
Okay,
So
let's talk about QMUX offline. So,
Okay.
and we can talk about it in quick tomorrow too. Okay, Christian, maybe? I can't see you. Is it Christian next?
It is, but he has.
Oh, there we go.
Christian, audio also.
Christian?
You need to turn on audio.
Can we unmute? Probably not.
You haven't turned on the audio in Meet Echo.
Okay, Christian, for some reason, we can't unmute you and, well, maybe I can unmute you here. No, I can't.
Okay, maybe Lucas can go and Christian can type in the chat.
All right, Lucas, go ahead. Maybe Christian can
Hello,
figure it out.
can you hear me?
Yes.
Yay. I'll be brief. I think, yeah, this is a bit of a pain. There's lots of QMUX questions. We've only just adopted the draft. Come to the quick working group session. We do have some time to talk around this topic. I suspect we'll need more time. I don't know if maybe it makes sense to kind of get some of the QMUX folks to come to the MOQ interim meeting in June and just schedule some time there to like do a co-hosted hour or something just to keep nailing down on this. Some of the pain points remind me a bit of some of the issues we saw with like WebSockets over H3 and extended connect, and some of those issues that didn't really go away, we just ignored them. So yeah, do the URL thing you're going to do, but I do think the ALPN stuff will need to get solved. I do wonder how much of a problem it is at the end. While we're iterating, sure, we'll need to figure out how to do different draft versions or whatever, but I'm more focused on the end goal. Like in 2 or 3 years' time, does what we produce make sense? Because even today, things don't make much sense, and it's kind of a pain. Thanks.
Okay.
All right, Christian, if you want to put your comment in the chat, I can read it, but in the meantime, we'll just move on to the next slide.
Okay. Thank you. Next slide. And this was Will's slide, and since we're a little bit short on time, but like, let me, in MSF and CMSF, which are things that run over on top of MOQ-T, those drafts have specified like meetings for the fragment that are not related to the connection, but they're sort of instructions to the client about what to do after the connection happens. Like after you establish a connection to this URL, then you want to send a subscribe to this track. And there's other things there. Go read the drafts. The question was, one question from the slide of like, should we include transport preferences here? I'm sort of inclined to say no, but I have a bigger question about fragments, which is on the next slide. Which is, so those MSF and CMSF are going to plan to use fragments, which is fine. So what, if anything, do we need to say in the MOQ-T draft about the fragment? Like, do we just say we're not defining one and other people can define them and they mean whatever they want? And if whatever running on top of MOQ-T gets to define their own fragment, then do we need to like require that they identify what they are so that a client that supports more than one will be able to correctly interpret the fragment? Or do we just not say anything and make it MSF, CMSF problem and let the chips fall? Ted.
Ted Hardy speaking. I'm a little confused about why you would want to use fragments for this rather than a parameter. There are lots of ways inside a URI to include a parameter. And if you do it with parameters, you can name what the parameter is. You know, just like as pointed out in the thing, SIP uses a transport parameter to tell you what the underlying transport is. You can use parameters here to convey instructions to the client, and you can have more than one type of parameter if you're not trying to use a fragment. in general, fragments are defined in the URI system as specific to a MIME type. So a fragment in a particular MIME type has a particular meaning. You're not really using MIME types in this. So although fragments are a valid part of the URI syntax here, I don't think they're actually the one you want. I think you want parameters instead.
Can I ask a follow-up question? Because, and I know this discussion has been going on for a while in MSF, and I've been in and out of it. One of the things that I think is confusing about parameters is some of those parameters might belong to the web transport resource, and some of them now you're saying don't, that they're actually instructions to the client and they don't get sent along. And that's, and Martin Thompson in the room says that's what fragments are for. So I think that's why we went for that separation. You can imagine if the URL is signed, for example, like we can't strip out these things that only the client's supposed to see from that part of it.
So the use of parameters is scheme specific. So if you define a particular set of scheme parameters, which are either mandatory or optional and have specific meanings, then you can define what part of the consumer of that URI it's addressed to. Now, it sounds like Martin said to you, the reason you went to fragments is because those are always referenced by the final consumer because they're the consumer of the MIME type. That's true, but because you don't have a MIME type here, you're running into this problem that if you want to have more than one kind of fragment, you don't know why this fragment is different from that one. And you would know that in a URI scheme that was referencing MIME types by them being different fragments for different MIME types. So unless you invent MIME types to go with this scheme, the fragment is going to have that ambiguity where I don't think the parameters would. Now, as I said, syntactically it is valid. So I'm not going to like get up here and put on a purist hat and said thou shalt not. If you want to go this way, it is a valid syntax, just a little confusing. But I think it's going to retain that ambiguity where some other mechanisms might not.
Okay, I'm going to close the queue very shortly. So if you want to enter it soon and be brief, please.
Yeah, Will Lowick, am I? So I am a supporter of fragment. I think Ted's made it clear that there's not the direct MIME type association, but you're allowed to, it has the very clear understanding that this is not information for the server. And with these URIs, we're munging two things together, as you've mentioned, how the client connect to a resource, and then what it should do at the application layer once it's connected. And we're putting that all in one string here. And I think having constraining information that's purely for the application, the client application, putting it in the fragment makes syntactical sense. And I don't think MOQ transport should define what goes in the fragment. There are going to be hundreds of applications that run on top of MOQ transport, and they're going to invent very different ways to communicate their application-specific information. And we should give them some freedom in how they choose to do that. We should just define the MOQ-T schema, which says how you connect to the MOQ-T resource, and step out of the way.
So Will, I wonder, I mean, this discussion about MIME types, and I admit I'm a little bit weak on it, but I wonder if there was a way that the server identified which MIME type it was, then you would know how to interpret the fragment.
I don't think the server doesn't need to do that. In this case, it's just opening up a communication channel, right? It's not actually returning a resource. It's establishing a connection.
Yeah, no, it's weird. Okay, we can drain the queue.
Mike Bishop.
Yeah, no hats on, just I think the difficulty with putting it as a parameter, which we discussed at the interim, is that winds up becoming the address of the web transport resource. And what we're really, ideally, we would like to have multiple layers here, but the URI syntax doesn't give us multiple ways to slice it. I think fragments do kind of make sense, but as they're defined, we essentially would paint ourselves into the corner of having to define MIME types for MOQ-T, which isn't great, but maybe what we wind up doing.
Harold.
Harold Alveston, Google. speaking as with my hat of a media man chair. There's an awful lot of existing practice around fragments, and a lot of it ties strictly to you interpret it in the context of what you got back, not how you connect. I think it would be advantageous for the sanity of the internet ecosystem if MOQ kept on using that. I mean, the sharp is just a character. You don't lose anything by doing something different.
Thank you.
Okay,
All right.
Colin, you can go as long as you want, but it's going to come out of your secure objects time. So it could be brief.
Nothing to say. So look, be pretty quick on this. I've spent hundreds of hours when I was chair of the DAV working group on this topic. It is deep. And I'm going to totally ignore all of that. I don't care. Like it does. I'm just going to treat this as some bits on the wire. There's a hash mark. There could be things to the right or the left of the hash mark. I don't really care how we arrange those bytes right or left of the hash mark, because it won't matter, because these implementations are not something else. They're a MOQ implementation. When we talk about a web transport in a relay, it's not like it's a standalone thing. It's a web transport sitting under a MOQ relay. It knows how to interpret these parameters and knows what they're defined as. The thing that's important to me comes back to Will's point, which is lots of apps are going to need to extend and define these parameters. And because of that, I think we should very well define in our URI a structured way where you can put named value pairs, regardless if they're on their right or left-hand side of the hash mark, in a way that's extensible. And that extensible part should be in the base draft. Then defining a bunch of those and saying how they're used and which one of the things they're used by, the client, the relay, they're removed, they're not removed, they're encoded in EPSIDIC. That should be up to the places that use them, but we should have the base structure to do it. And this just seems like the most pragmatic thing that we can do. And I guess we will have to figure out if it's to the right or left of a hash mark, but I don't really care.
Yeah, I mean, just like that is sort of where I was coming to, which is like, I feel like in MOQ we should say something like, let's imagine we're using fragments. We should say something about that in MOQ, like MOQ applications can use the fragment in this way, but I would also like them to be self-describing in some way. So I got to look at one. If I support more than one as a client, I know what to do with it. So anyway, that's all I want to say. And now I'm going to give it back to Colin.
Okay, Colin, go. Timer's already running.
Welcome to MOQ.
Okay, I will switch to the other thing with my AV support crew. Okay, secure objects. This has been moved into a working group draft. Thank you very much. We're trying to reflect consensus as best we can. I have slides up here. I can look perfect. Next slide. For people that have not been, slide I can barely even read. For people who have not been involved with this, we have the issue that relays can read all of our data we send them, right? We have TLS protects us on hop by hop, but not the end-to-end. And for some of these applications, there's a lot of relays in a lot of places in the world with a lot of different access, and people are for some of the more secure communications, that doesn't mean it. You need something secure where you can also encrypt things end-to-end in addition to what you're doing by hop. Next slide. So what we have done in the next slide, if we can get there. Yeah, no worry. Okay. So what we've done in previous meetings is we've sort of split things up into 3 categories of some stuff that the relays can basically read and modify, add, delete, all of those things, some things that they can read but not change, and some things that are end-to-end. So that's roughly the main goal of where the draft is today. Next slide. Bunch of issues closed. Next slide. And we've got some open ones that I'm going to be talking about here, and we'll jump into some of these going forward. So next slide, please. Okay, one of the questions is, we have this field of data where we take a bunch of things and we add them to the AAD data for the encryption. So this is stuff that will be integrity checked, and we will check that it hasn't changed when it arrives at the far end, or else we'll get an error. But it's not sent over the wire. That's a key thing here. And this sort of grew over time and was a little bit hatched. So some of the stuff like key ID, we had it in here. You need the key ID in here, and it matches S-frame also has key ID and its counter in this same thing. And then when we put the key ID also in the immutable properties, obviously you don't need the key ID twice in this. That's ridiculous, right? So there's just some mistakes made like that. The track namespace well, I'll talk a little bit more about the proposal, what to do on that, and why it is. But it's so that the thing we're protecting against is cut and paste of an object from one track to a different track. So we need something that checks that was right. Next slide. So the proposed solution of what we're putting in here is track name. And the reason, and I'll get to ordering this a second, then the immutable properties, which includes the key ID, the group ID, and the object ID. This pretty much mirrors what is in S-frame with the exception of track name, which doesn't quite have the same concept there. The reason track name is here is it's not part of our key derivation because the keys are bound to the namespace, the track namespace, and the track namespace is part of the key derivation. The whole reason that when we previously decided on that with design was so that if you were subscribed to a namespace and you started getting publishes on it, you had the keys could be scoped to that. You could have different keys for every track, or you could have a key to the namespace. So the reason track name was put first in the ordering here was you might be able to partially compute a hash along the way and reuse that pre-computation. I don't know if that works or is relevant. So this is something that needs more discussion and more review, but this is sort of proposed solution we've been looking at right here. Let me stop there. Comments on that? I see a couple people in the queue.
Victor.
Can you hear me?
Yes, we can.
Yes.
Okay. I am seriously concerned by this notion that the keys can be reused across different track names because in different parts we rely on group and object ID uniqueness as the guarantee that we do not accidentally reuse the AD numbers. And it would make more sense just to rederive the key for every track name because that is not actually expensive. And I mean, subscribing publishing is to some extent like an operation that is kind of expensive. So I think that would, yeah.
Okay, so Victor, you're suggesting that the track name should be included, that basically you're suggesting the key ID should be bound to a track, not to a track namespace. No.
Yes, I'm also concerned that if they're bound to a track, then you will basically have a nonce reuse if you have same group object ID between different tracks.
Okay.
Mo?
Yeah, I had the exact same. Was there a decision to cut things between namespace and name, or it just wasn't considered all the way? Was there a good reason why you wanted to have the namespace part of key derivation and not the name, or it was just an arbitrary cut point?
It was not to avoid the computation of having more keys, but so that if you received a track in a namespace you'd subscribe to, that you could set up ways where it was encrypted that way. And like, look, this was long ago. I'm happy to pull this out. It was just I was trying to match up with a prior decision.
I agree with Victor that it makes more logical sense, and for security properties, you want whatever the key is to only have one nonce space, and this would guarantee that you have one nonce space with the group ID and object IDs.
Right. I think the non-space is actually independent on this, but well, never mind. Let me retract that statement. Let me just say, okay, let's take that as just a note going forward. Unless some other people are objecting to it, we'll make that change in the next draft, unless we get objections.
Alan?
So my question's about the properties, and I saw an issue in LOC which referenced the properties.
We got slides coming up.
Okay, well then maybe I'll wait for that, because I think we need to talk about how the track properties, or is it track properties or object properties or both, and how that works.
Yeah. That's actually probably the biggest issue in the presentation coming up.
Okay,
here. So
sweet.
That wraps this one up. Next slide. Variant encoding, this is byte shetty. Obviously, we have to have a canonical way to encode these integers. So the two ways that propose is we always use 64-bit, like we expand them out to a 64-bit integer when we're validating them for the integrity checks. Or the other way is we always re-encode them as the shortest number of bytes possible. We're probably generally sending the minimal overhead one on over the wire. Right now, the draft says should. You should do that, not you must do that. I think, does anyone have any arguments to be made that might push us heavily towards solution 1 or solution 2, or if they don't care? Yeah, give me some feedback on what to do here. Martin? Oh, please.
Martin Duke didn't need to run, I guess, but I don't really care that much, but I would say number one, we don't actually need to put it on the wire. Like you could just, as part of the processing, expand it to 64 bits when you do the.
But the slide is a mistake. It will be exactly the same on the wire. I don't know why I wrote that. My apologies. It is not more bytes on the wire. It's the same. You're
Cool,
right.
thanks.
Yeah.
So I think on Thursday, I also have a slide about minimal variant encoding. And Victor had raised a point about it. I don't know if we want to get into it here or not, but the con for requiring it has to do with like, are there error conditions in your variant decoder? And if you say that everything has to be minimally encoded, then there are now error conditions which are different from I don't have enough bytes, wait for more. So that was one. The other one is I'm not sure I quite understand why this is a problem. We added text in the draft that said like, when immutable properties pass through a relay, like you have to use the same encoding that the publisher used. And so isn't that fun? Won't it still work if you don't change it?
I'm not, there might be some things that aren't sent over the wire directly here that are included in the AAD. I can't think of one off the top of my head.
I guess I'm saying I don't understand. I'm not sure I totally understand that there is a problem that we have to say something about here.
Mo, I think there is a problem. The blob that we came up with, that Victor proposed a long time ago, brings everything to be serialized. So I think that's not a problem. It's already serialized, and it's probably serialized with minimal encodings. So I would bias towards going with minimal encodings because you're already going to have that blob, and you don't want to unpack it unnecessarily for your AAD functions. But then there's things outside of that that are also part of the AAD, and they're not already serialized. They're not already blobs. And for those, we should be specific about those. And I would only caution against mandatory minimal because I'm aware of some uses of variant that hack things like using the aliased code points as other things like not a number, negative infinity, positive infinity. So, your 4 zeros are not actually zeros. They're code points for other things. So that's the only problem that I would run into for specifying mandatory minimal encodings.
Okay,
that sounds like a bigger issue for Alan.
No, okay. So I'm sure. So where you're trying to do this is like when you're
trying to do it two places. One, you've encoded up a message. You're about to effectively sign that message and send it, or to compute the encryption stuff for it. And you largely already have all the bits of the encrypted message. That's one spot. And then the more common spot is effectively exactly the opposite. You've received a message. You've parsed it at some level. You have not passed it up to the application yet, and you're trying to check it's a valid message before you let the application see it.
Okay. I'm still. I still think that as long as you keep the same bytes from the beginning to the end, it doesn't matter what we choose.
Okay, so you're saying a third one that I didn't say here, which is like you use what was sent on the wire.
You use what you got. Is kind of and just about minimal variance. I think I was talking to Ian the other day. He said, "Oh, sometimes hardware people are like, no, I really want to be able to use the like 5-byte one because I need to like."
They like it.
Use the other bytes for some other hardware.
They want to get like some AES operation 8 by the line.
Yeah, I mean,
Look, I'm one of those people, like, we often are trying to align things so they're in fixed positions in the message and they don't move around. And the easiest way to do that is use the max size message for every integer, and now everything stays in the same spot, right?
Or sometimes you use like a 5 byte number because like you have 3 bytes of other stuff.
Yeah.
Or weird, yeah.
Okay, look, I want to move on for this one, and I'm not quite sure how to resolve it, but maybe after the next discussion, maybe after the discussion about the generalized issue, it'll be easier. And I'll add the third possibility and get a bug open on this. So action item for Cullen, make sure that the issue is expanded to have 3 proposed solutions. Next slide. Okay, we've got a bunch of stuff that we're still working on the security properties, and this is stuff that I'll be working on these ones, but like this doesn't change the on-the-wire protocol. This changes our explanation of the security properties of it. Next slide. And I think we're to the hard one here. Okay, so right now we have track properties. And this draft doesn't really provide any way to encrypt traffic or deal with integrity or encryption or any end-to-end properties of the track properties. And we're starting to put relevant stuff there. So I've got a range of options here, and I'm going to walk through some slides for them. But briefly, one is, don't do that. Like if it's something you want end-to-end integrity for, make it an object property instead of a track property, and put it in the first object that is one thing, right? The second one is only provide authentication for track properties, and you can't check that the track properties were valid until an object arrives. I'll explain how to do this in a second. And similar with encryption. And the fourth one is, I think as Alan sort of proposes, is, make in the same way that we did this for objects, do a similar thing with, have different keys, different none spaces, et cetera, for having a way to provide end-to-end for parts of the track message. So next slide. So I'll go through each one of these in a little bit more detail. Oh, actually, the first one I'm not going to go through in any more detail. It's pretty much don't do it, right? Okay, so this is option 2 and 3. And what we would do is when we're computing, so I'm going to talk through option 2, which is just about authenticating the track properties. What you would do is every time you were sending an object, not sending a track message, not sending a track property, you would include all the track properties in the AAD data that you're authenticating for every single time for all of the objects. So later, when you get to the far end, and you are checking that the message hasn't been tampered with, you again do the same thing. You include all the track properties there, and if any of the track properties were mucked with in the transports, they would fail the integrity check here. And of course, we'd have a container of which track properties needed to be in this category and which ones weren't. So the weirdness about this solution is you don't actually find out your track properties were tampered with when you receive the track properties. You find out they were tampered with when you receive the first data object and it fails. And actually, you don't even know whether the object or the track property was tampered with. You just know something was broken. Does that make sense? Like, not discussing pros and cons of this solution. Does it make sense what I'm proposing there? Okay. I'm seeing nods in the room. Okay. The next one is people are like, yeah, but I want encrypted track properties. How do I get those? Okay. And basically, we form a blob that we put in the objects. In the first object of the group, we include all of the track properties that need to be encrypted as an encrypted object parameter, effectively, instead of sending them as a track parameter. And I started writing this all down and sort of trying to write it up. I'm like, this is crazy. I'm right back at where I was of option 0 at this point. I'm at the point of just make the track properties be object properties and put them in the first group. I don't need any extra mechanisms to do this. So that's those two class solutions. Now I want to go next slide to the last class of solution. Here is option 4.
We have people in the queue. Do you want to?
Oh, sorry, I missed that. Yeah,
okay, Richard.
We can't hear you, Richard.
Yeah, I was having to click 5 more Meet Echo buttons to give all the permissions. Just an observation on option 2 here, in light of the previous discussion about hashing things into the keys. If these track properties are constant over the lifetime of a key, we could just hash them into the key and not have to add them to the AID.
Oh, that's an excellent point.
Alan?
That's a much better design.
On 3, I don't see why you couldn't have an encrypted track property also be a track property. Meaning you could validate it.
That's option 4.
Oh,
we get to option 4. Yeah. Yeah.
Need bigger slides.
Okay. Next slide.
Magnus is quick.
As individual, have you analyzed what in the track properties could you actually do if you were a rogue relay? Because I think that's the core of the issue. Is this a real issue or not? Or it's something which falls in a reasonable, trusted relay, and it can always do much worse by not forwarding objects, groups, etc. So is it actually needed to be solved?
I have not, Magnus, and I think we're sort of at an early stage of understanding what track properties would be used to. There was some for video initialization type stuff that seemed to me like they might be things that you wanted integrity on, but I don't know. I think we need to talk about what our requirements. I mean, that's my end sort of, punchline on all of this is I don't think we understand what our requirements are here yet, much less what the solutions are. So
you have 4 minutes remaining, Colin.
Okay, so skip this slide. I've already talked about this. Next slide. Okay, so this is option 4, and this is the one Alan was talking about a little bit, which we form a whole, we form another, we put encrypted or integrity protected things in the actual track messages, and we, when we receive them, we have another information to decode them. So this would probably result in needing a different key ID, a different way to set up. Some of the things that's a little bit not 100% clear on this is how we would deal with the nonces on it. I think that we would probably just include the nonces completely in the message and send them along with it because we're not really worried about the bandwidth of control messages. So a bunch of this stuff may be much easier. But I think that we need to poke around with this a little bit, and I think it'll need some changes to the MOQ-T base spec as well. I don't see it as a problem. They'd be minor things, but we need to set this up. So I don't have a concrete design for that, but I think that we would just be basically designing an independent, track encryption and track integrity protection scheme that went over the control channels versus instead of the data plane. Next slide.
Once again, Mo, you're in the queue.
No, just finish. Go ahead and finish everything, Colin, and then I'll.
Let me just check what the last slide is here. I think that is everything.
This is the last slide.
Okay, so yeah, perfect. Let's run through.
Oh.
So yeah.
So I think the last option is better because I think it's better to actually authenticate what's in the control message and do it once, not try to hack things in. I think the track properties have caused a lot of confusion because people are using them like, data plane compression. They're trying to take all the object properties that they thought would always go all the time and just compress them up into the track property and trying to go the other direction, pushing them back into the object, crypto work. It doesn't make sense to me. I think this is cleaner. It makes more sense. I don't think you need a nonce. You could just say that you cannot have more than one of these. This is the only nonce is 0. Force the IV to be 0. You can't have multiple of these things.
I'm going to close the queue soon, but Suhas.
I prefer option 1, just because we have a machinery that defines how these things work, and the nice thing about option 1 is that if the publisher wants to update a track property at the data plane, it can do it in object or group boundary, which is typically the case when you're doing video config and you want to change the region of orientation or the region of interest or orientation kind of things, which are more of data driven rather than a control message setup. Having send a control message to update at the same time, wait for the objects to come, and then have the time shared between those on the receiver side to work on it kind of breaks the pipeline of I got an object, I'm going to decode and verify things. My preference would be to option 1, simple, unless we have a real need for something more complicated, not prefer to add complications here.
Richard, but please be succinct.
Yeah, I'm not an expert on the application domain here. I would love to have some more detailed requirements for this stuff. Maybe I just need to read some more things. But this number 4 seems like the most complicated thing. It goes beyond the base thing in that it requires a whole new key management scheme. We had this whole notion, at least in the base thing, that you have keys assigned per track, which is a nice clean boundary, aligns well with MOQ concepts. Here is some other thing that we need some other notion of key management for. So I would really hesitate to do this option 4. I think option 1 is great if we can get away with it. Option 2, especially in the hash it into the keys, seems totally reasonable and doable, but yeah, let's not go past that.
Rohan.
I'm also this also 4 does also seem pretty complex to me, but my reservation with option 2 is that is the debugging this is going to be a nightmare, and like even if there is even if you had you received something immediately and it was the first, you got a message directly after you got the track information, you would still be really difficult to figure out what happened that caused your error.
Okay, so here's my ask for people. If people who are using track properties could think more about what the requirements are here and some use cases where you might want integrity or you might want encryption on track properties and send them to me, that'd be really useful. And I don't know, maybe I'll write up proper PR for option 4 and option 1. I don't know. We can debate, but I don't think we have enough to make a clear decision right now. I mean, we need, right. Option 4 might look less complicated if it was written down, is I guess one of the things. So.
Okay, thanks, Colin. Next up is Thibaut.
Okay, sound working? Yes, no, maybe.
Yes, it works. We hear you.
Okay, good. Well, hey everyone. So I'm presenting a draft that we're doing with Suhas, Colleen, and myself. And this is an update on the privacy pass authorization for me over QUIC. This slide meant, and through the slide deck it's mentioned it's draft 3. This is actually draft 2 that has been cut. This is a mistake that went through the slides. On that, next slide. So quick reminder about what is Privacy Pass. So core concept provides unlinkable tokens, so you cannot link issuance and redemption. There's blind issuance, which means the issuer doesn't signs or issues token without actually seeing the token content. This is single-use tokens that are redeemed by the media over QUIC relay, which prevents replay while being privacy preserving. And the separation of concern, at least architecturally, which means the attester, the issuer, the origin, and the client are all different and are all different entity, even though they might be operated by the same entity. There are separation of concerns here. On that, next slide. So what does it matter for media over QUIC? The core idea and what we're looking to have here is to have some annual subscription where users can subscribe to content without necessarily revealing the viewing patterns. There's still some need to have some fine-grained access control, such that the token encodes the scope of the namespace and the track name. There's some separation. So there's some separation between the relay that validate the token and the user identity. That's the main benefit that we see with Privacy Pass. And finally, we provide some badge token or some unused credentials such that we can have more long-lived session without necessarily having to redo the attestation flow, which might be costly over and over. So we have some privacy. We don't see the relay doesn't learn about the viewing pattern. It remains private to the user. There's some scalability, meaning the the fact that like the relay can validate the token allows to avoid to how to say like go back every time to the issuer, no matter like the amount of subscription that like one user does. And finally, we tried in the draft to integrate with like existing token types such as like blind RSA, VOPRF. Also have some consideration for like new constructions such as ARC, which have been recently adopted in Privacy Pass draft, even though that's more experimental at the moment. Next slide. Okay, so one of the things that I would try to integrate more of the concept is like the reverse flow, which allow like the origin, like the MOQ relay to reissue tokens after bootstrapping from the issuer. So from a client perspective, the client first goes and perform an attestation, which gets them a token. Once they've obtained a token, they exchange this token with the relay through like a client setup phase, and with like the server setup, they receive either like one more token, a batch of token, or like a credential. This is part of like the reverse flow. Then down the line, like through the operation, after each session, and to make the sessions how to call that like unlinkable, the client can request will present token and can request new token that the MOQ relay will reissue. The changes that we had since the last draft, specifically on this slide, is like we've updated the setup to client setup, and like the various code points to the latest MOQ transport draft. So this has been updated in the draft as well. Next. So the benefits we have from having such a reverse flow is it allows to like more easily bootstrap from an external issuer using public verifiable token, and then the origin can like bootstrap using this token to like reissue token of their own. There's possible integration with like rate limit tokens to provide some presentation limit for rate control across namespaces or track names. This is something that like really would have to be more fleshed out. On the privacy side, each token presentation is unlinkable, even for the same credential. So even when the MOQ relay acts as an issuer itself, there's still unlinkable presentations. In terms of efficiency, reverse flow could like allow for having like batch issuance. So like from bootstrapping from one token which is provided by the initial issuer, the MOQ relay should be able to issue more token that could be used for multiple operations. And finally, these various token could allow to provide some continuous like authorization. The request of new token in line with the operation for long session should allow for that. This is something that we've tried to illustrate in the slides. So if the client at setup time present one token, they can also request one more token that will like be issued by the server. When the server, like when the client comes back and say, okay, I want to subscribe, they can like present like this new token that has been provided by the server at setup time, get one more token, and then again later in time, like when the client wants to perform like a publish operation, they can present like that last token that they've obtained. What's important here is each of these operation like is unlinkable. Each of these presentations are unlinkable. The relay may correlate operations through other means, but at least from like the authorization perspective, that they should not be able to do so. Next slide. One of the things that we've introduced like with the draft is better error handling, which has been detected through like a very first early implementation of the previous draft. Mostly like we have like, for instance, like an error code registry, which we've received like some reviews from IANA, which will like file issues for and try to address. This error code registry allows to have better understanding of like what's happening through the flow. Is like the token missing? Is it invalid? Has it expired? Has it been replayed? there are possibly some like extensions to make to zero code, but at least like this is here so that we can extend it down the line as we learn from like the various iteration and implementation of the draft. Next slide, please. Okay, one of the other big question that we had in the previous draft that was open is like, how do we do actually like, how do we match on action? How do we match on track names? How do we match on namespace? So this is something we've introduced like through this draft. The way it works is like we extract the token and we add some some matching flow along with it. So the flow which is on the right, we extract the token, verify the token if the signature matches, and then as part of like the replay protection check, we check multiple of these possible actions. So is it like a client setup? Is it a publish? Like is it an action for like a publication of a namespace? And the track name, the track status, etc. That we have that through. Once, oh, sorry, thank you. So what I was describing before, which is like probably like a bit more concrete here, like about the matching type for the track names or track namespace. It's part of like the token that is signed like and presented to get access. The scope, which we've described before, so like if I want to do subscribe operation as of here, I would say I want to do an action, the type of match, and the value. So like here, if I want to like watch live sport, the value would be live sport. This is a prefix because like there might be different lives that are happening at the same time, and this is something that would allow like for like extensibility down the line. There's also a wildcard for like an empty value. This is something that like is like definitely fresh and like would benefit from like some more like further review, I think, from the group. Next slide, please. Okay, so what are the next steps? We have new INI registries which have been reviewed by INI. So like as I mentioned before, that's something that like we will need, like we'll open issues for. There's been a couple of like ranges and like issues flagged here. In addition, the security consideration is like still empty, so that's something that like we need like to be filled. And yeah, open to questions. The chat has seemed to be active, but I haven't been able to read. So if you have a comment to make, like please make it to the mic.
The queue is open. Going once. Altanai.
All right. Hi, Altanai Cisco Meraki. I have two questions. This is question one. Can you elaborate how this relates to multiple relays, like a chain? Does everyone have to get a token? Every hop has to get a token? Oh, do you want the question two?
So I think it really depends on like the type of deployment you're looking for. I would say yes for two reasons. One of the reasons is a lot of the efficiency that we gain, at least in the implementation, is due to like the type of token that we're using, which like are only scoped when the relay that like issuing the token is the one verifying them. So like we cannot chain the relays if they are like operated by like different entities. And the second reason is even if we had some sort of like token which were verifiable by each and every entity, this might allow for like potentially more linking. Again, given the relay are communicating between each other, that might be like an acceptable like privacy leak. But ideally, yes, they would need each and every relay would need like their own token.
Okay, so then not considering the performance overheads, which are obviously there, you're making it unlinkable from the relay's perspective. This is question two. So the relays have no idea who's whatever asking for what, but the issuer has all the scope it needs. So now the issuer has all the data, what stream was requested, what client requested it, everything. Or maybe I don't know privacy pass as much. how do we de-risk all this leaking happening from the issuer side?
Yes, so like the issuer still needs to know, like you need to get access to some resources. So like the issuer still needs to know that like you want to, like for instance, like are you allowed, like do you have like a subscription so that you can watch live sports? But like they don't necessarily need to, like they won't know which live you will watch. And so like this is something that like would be at the relay and the issuer would have no information about.
Okay. All right.
Alan? You're muted in there. Did we do that?
Go.
Oh, never mind.
Okay, so one, I see people squatting on code points that we don't have IANA registries for yet. And we've already had problems with like MOQ comes up with some use case, like I mint error code 100 and now all of a sudden I've broken your draft. So let's like try to coordinate and like we'll just keep an appendix in mock transport in the short term until we have created registries. We can use a Wikipedia entry, says David. So that's one thing. So and this is for any authors who have any drafts that have any code points that go in any of the things that are now greased, like please send them to us so we don't blow each other up. The other one was about chaining relays, and the pursuit, like parameters are hop by hop and tokens a parameter. So there's no guarantee that any relay is going to forward any token sent to it. And think also about how subscriptions are aggregated. So a subscription may come to the first hop relay. It already has an upstream subscription. It's not going to send another one upstream. So this has been like mentioned in a few different contexts before, but if that's a deal breaker, we need to know.
Lovely. Thank you, Thibault. We're going to move right into Suhas's presentation now. You can find it. There it is.
So, can you hear me?
Yes.
So I'll be talking about application agnostic Depop framework. The focus of this draft is enabling sender constraint tokens for Meteor QUIC. We presented this draft at the last IETF at OAuth working group. I'll bring in some context of what happened and why we are presenting this here. Next slide, please. So to motivate, like, why do we need a new draft for Depop proofs in MOQ? The CAT tokens that we use today, that there can be two types. One, either they can be bearer tokens or the tokens that are sender constrained. The challenge with bearer tokens are the nice thing about bearer tokens are they're simple, but they have security implications. Sender constraint tokens provide stronger security guarantees, whereas the bearer tokens can be easily replayed. A position of the token means equals to authorization, so there's no ownership. Whereas with sender constraint, to use a token, one has to prove that they have bound a key, client's key, in order to access. So if I just copy a sender constraint token, I cannot just reuse it because I need to prove that I have the possession of the private key. The challenge with current CAT Depop claims is that they are bound to HTTP request methods and URIs. But since MOQ works over QUIC, we need some way to kind of, if you want to support a Depop in CAT for MOQ, then we need to kind of enable that the Depop claims to also understand what MOQ is. So the scope of this draft is define Depop bindings specifically for MOQ protocol messages, fills in the gap basically left by RFC 9449, which is the Depop RFC, which is HTTP specific approach. And this draft does not include any new security concerns. It builds on already proven mechanisms. Next slide. What kind of, if you can jump slightly one step deeper into what kind of attacks, attack vectors that we see with token today, and where the Depop or sender constraint requirement comes into play is that if you think of a compromised relay where a malicious or breached relay can extract these bearer tokens for MOQ connections, then these tokens can be distributed through a botnet, and that would result in millions of unauthorized subscribers subscribing to those streams. This is kind of equivalent content piracy at scale and resource exhaustion. In a similar kind of way where anyone who has the token, they can replay the token, where the attacker does not even need to have the private any keying material to prove that they have that they are bound to the token, so they can just replay. And some of the attacks that we can think of in a web browser kind of environment where malicious cross-script attacks, the scripts can basically steal the tokens off your memory or storage and can replay it. So where in all the use cases, all the attacks that kind of listed here, the main thing here is that the DPOP would not let an attacker to just steal a token and reuse it, because they need to provide a proof of possession of the key that's bound to the token. Next slide. So why are we bringing this work here again? We discussed in the IETF 124, we did present this at the OAuth working group. Some of the recommendations that we got from the security AD and the OAuth chairs were, we have a long-term vision within IETF where we might want to establish an OAuth directorate, which would help multiple working groups who need and help in order to kind of extend anything with OAuth or define some security requirements with OAuth. There might be a directorate where people can come and ask and get some answers. But there's nothing in place right there. The near-term strategy kind of felt like, since MOQ is the one that needs a requirement to have, if it needs to have a requirement for sender constraint CAT tokens, why not we do this work at MOQ? But OAuth will provide a knowledgeable OAuth expert who can work along with to make sure that we are not making some crazy assumptions here. I think the next set of action items is that we need to circle back with all the chairs and ADs from both MOQ and OAuth working group to have formal coordination here before we adopt this draft in any form. And we also want to kind of look for consensus on the right house for this work to continue. Next slide. I think I'll skip over this one because this kind of shows the attack vector is talking about, where an attacker can steal the token and can replay as long as it wants until the token expires, because it doesn't have to prove that it possesses the token. Next slide. This kind of goes one step deep into how DPOP works, where a client uses its, when it goes to the authorization server, it basically provides its proof, a DPOP proof, and when it makes the request, and once you get the token signed with bound to the client's public key. So whenever clients wants to go to the resource server and kind of want to ask a particular resource, it provides a new DPOP proof that proves a binding to the client's public key, and hence you're able to prove that you own that token or you're bound to that token. And the only challenge with RFC 9449 is that it's limited to HTTP methods, as we talked about. We need to kind of expand that to support MOQ messages. Richard. Yeah. Go ahead, Richard.
Yeah, hi. On the point about threat model, I was just going to expand that and say, in addition to this token theft points, there are some MOQ-specific considerations here that make it extra important to have these DPOP proofs. If there are multiple relays between a source and a destination, say a publisher or a subscriber, like any of those relays can impersonate and claim credit for a client's authorization if these authorizations are bearer tokens. And so, in addition to there's token theft by people breaking into an endpoint. There's also token theft by relays, observing tokens and replaying them in a different context.
Thank you, Richard. It's a valid point. Next slide, please. Okay, the proposed, what are we proposing here is that a general claim called a context, an application protocol context, that identifies a couple of things. One is the type, basically identifying what transport protocol that you would want to support, and a set of parameters, a set of sub-claims within that type that defines, for example, for the MOQ as a transport, it defines what are the actions that you want to apply this token on, like subscribe or publish, and it also has some optional parameters like what track namespace and track name you would want to apply. But the idea here is that we have a generic application context claim, and that can apply to any protocols of today and also in the future. However, the key point here is that the token acquisition remains unchanged. So we are not changing anything about how the token, we get the token. We only modify how the proofs are bound to non-HTTP operations. So existing OAuth infrastructure continues to work. Next slide, please. This kind of goes with one step deeper into the application context that I talked about, where it identifies the type MOQ is one that is defined in this draft, but it provides a registry for someone in the future wanting to do for co-op, for example. They can come and define a new draft based on that one. But our draft kind of talks about MOQ as the protocol identifier and defines an action, which could be one of the MOQ verbs that we use. And it also identifies the context on which the action works, in this case, the namespace and name. What happens is that in terms of validation, once the server verifies the action is allowed, after verifying the depop proof that this token is bound to the client who's saying for whom this token is valid, it validates the action, it validates the namespace, and performs in replay. If based on the nonce, it can know that has this token been replayed or not. Based on that, it validates this action to be successful or not. Next step. The next slide, please.
So
and the
Josh,
draft
we've got about 5 minutes, so I would encourage you to speed up.
I'll do that one. Thanks, Martin. So we defined two formats for the token. One is the JOT and COT. JOT because that's what the HTTP kind of depop draft provides, and COT because CAT is based on COT. Next slide, please. I'll skip over this one. This just shows in detail about how the token acquisition flow kind of bind from the depop proof bounds into the client's key, and from there how a MOQ endpoint can use those tokens to talk to the relay, which is the resource server in this case, to perform an action. Next slide. And the security properties, as Richard said, one of the attack vectors are to kind of make sure that the replay attack or token theft kind of an attack does not happen in one relay. It can happen in multiple hops, in every hop where someone can observe the token. So definitely what we propose here is builds upon what RFC 9449 says for making it sender constrained, cryptographic proof for possession or non-spaced replay protection. But what we define kind of expands that in another dimension to show that there's the cross-protocol securities, because you know that you're using it for MOQ and someone wants to use it for HTTP in future, need not have to have collisions across different protocols, and it's bound to an operation and the context on which it's working on. And there's an application separation because it's defined per protocol type. Next slide. So some of the next step we would like from the working group is that we're looking for feedback. We're looking for input from the people who want to use sender constraint tokens, especially interested in deployment scenarios and requirements, and see how if what we are proposing makes sense. And also security reviews is welcome. We have an open source implementation for using depop in CAT for MOQ. The repository link is there, and we are looking for testing and experimentation with this, with that, and for interoperability as well. In general, about the working group coordination, we would like to have this ongoing discussion with the chairs and the AD across the two working groups here, so that we can decide the right working group to continue the work. So we need a formal agreement on where this work should continue, and gain the interest from the participants as well. Yeah, that should be all.
Okay, we have a couple minutes for questions and comments. If you want to enter the queue, please limit your comments to 1 minute. Alan.
Go. Okay, quick question. I know there was an issue opened a long time ago about whether MOQ needs a field to convey depop information, and well, my agent scanned your draft and said that it didn't say, so it's probably right. And I just want to know, like, it seems like we can probably carry any of the information that needs to be carried within the authorization token field itself, and we don't need to change MOQ. Is that true, or are you still on MOQ?
Yes. This does not require any change in the MOQ. One of the CAT, if the CAT token is opaque to the MOQ library, so the CAT library knows that there's a claim called depop inside CAT, because CAT today defines depop claims as one of the claims, but that depop claim is bound to HTTP. So if you want to use CAT with depop, claims in it, it has to understand MOQ. That's what this draft tries to kind of address. So MOQ core transport does not need any change based on this.
Okay, I'm gonna assign that issue to you to close. And if you don't
Sounds
close it, I'm gonna close it tomorrow.
Sounds good.
Thanks.
All right, if there's nothing else, we're going to move straight into switch, which is Will here in the room. While he's walking up here, I'll just say that if you are, yes, Will.
Can I present from here?
Why don't you come up to the mic? We have this, I mean, someone should use this. It's been here all morning. While he's walking up, if you are a proponent presented something, I strongly encourage you to review the Zulip chat. There's been a great deal of technical discussion on every presentation. So there's a lot of good input there for those of you who are proponents.
Thank you very much. Test, test.
Yeah.
Right, good morning. My name is Will Law from Akamai, and I'm presenting on dynamic track switching for MOQ relays. This is, you might want to refer to this as server-side ABR. And I'm representing the results of an ad hoc design team that met at the Boulder interim, and I've put the work into a separate draft, which is linked here. But this is give you feedback on the general design and also suggest some changes. So firstly, why are we calling it dynamic track switching? This is not a common term of art for media. And the reason is because we want to make it more flexible than just ABR, adaptive bitrate, right? MOQ can deliver things that are not media. So we might want to switch non-media objects, and we might want to switch them on properties that are not actually throughput. There might be other server observable properties that we want to switch on in the future. So we're making it a general term, dynamic track switching, but its primary use case right now is server-side ABR. The general approach here is quite simple. We define two parameters, right? Switching set assignment and DTS activation. I have slides explaining what these mean. The client subscribes to each one of the tracks that it might want to switch between, and then it tells the server, okay, go ahead and do the switching for me. And then it can turn on or off that behavior. It's conceptually quite simple. So let me explain the parameters. The first one is called switching set assignment. This parameter accompanies a subscription request. So the client's subscribing to a video stream, and in it says, hey, I want you to take this stream, add it to set number 1, and the minimum throughput you need to play this particular track is 5,000 kilobits per second, and I'm willing to let you wait 50 milliseconds before you decide not to send this object to me. And I have a separate slide as to why we need, or why we might want, a time limit involved here. So the client would add this parameter and subscribe to each of these tracks. And when the server receives those tracks, it puts them into a forward equals 0 mode. So it's not actually sending anything to the client. And then the client needs to say, okay, I'm ready for you to start switching now. So it appends on its last subscription a second parameter called DTS activation, which, as its name suggests, it just says, for switching set number 1, please start switching. So it controls the precise time at which the relay or the server starts implementing the switching logic. And this can both turn it on and turn it off for a set of subscriptions. Here's an example. It's a lot of text, but imagine we have a client wants to subscribe to 3 video tracks. There's a high, a medium, and a low one. It would subscribe to high. It would add on the switching set assignment parameter and say, I'm putting this in switching set number 1. Switch if you've got more than 4,000 kilobits, and I'm willing to wait 100 milliseconds. The relay receives that. It then subscribes to the medium one. It subscribes to the low one. And when it subscribes to the low one, it also appends that activation parameter, which is step number 5, and says, turn it on. So the relay now starts toggling the forwarding status of these active subscriptions. And it's always attempting to forward the highest bitrate threshold, which is smaller than or equal to its estimate of the connection throughput at the time that it's making the decision. And decisions are only made when the first object in a new group arrives. So this is group boundary decisioning. We're not switching on every object, we're switching on every group. So a number of people say, why do we need the waiting attribute? This is there to enable the algorithm to fail down if one of your tracks doesn't arrive in time. And as soon as we have a notion of doesn't arrive in time, we need to define a timeout, and that's what this waiting is. I really wish I could animate this, but I can't because it's a PDF. But we've got purple, blue, and orange tracks, right? And we're making our switching decision for the last group to arrive, which is group number 24. And the timer starts when the first object of anything in the switching set arrives. In this case, it's the blue track. So it starts the clock at blue. Now, if blue is my desired target track, this is the highest one, smaller than the bitrate, I would just forward that object and I would stop all other decisioning until the next group arrives, right? That's very simple. But let's say purple is in fact the track that I would like to switch to, right? So we start a clock at the blue one, and we notice that the purple has not arrived within its pre-declared tolerance, which was 100 milliseconds. In this case, the relay says, I can't deliver this, I'm going to fail down, I'm going to pick the next lowest track, which in this case would be the blue one, and it would send it. So the whole point of the waiting timeout is to enable us to have this fail down action. So one question for you. We could drop this time limit completely. It would simplify the implementation on the server, no tracking of time. What we would lose is the fact that you would only want to deliver the purple track because that's the right bitrate. And even if it never arrives, we just sit in this mode wanting to deliver it. And actually, this is how many server-side schemes work today, because it's an edge case. It's pretty infrequent that the track's not going to arrive at all. And if this happened, the client has other mechanisms by which it could detect this failure, and it could cancel this ABR and set up a new ABR set. So if we want to do that, we can simplify the switching set assignment parameter to simply indicate the switching set ID and the throughput threshold. No need for time. So this is a question for the group. I'm not going to pause here, but we appreciate feedback on this. Second question, should we add in a new fractional attribute? And the argument here is the server's estimate of the throughput, especially coming from a congestion controller, is for the entire connection. So imagine I'm a client that I'm trying to listen to 3 speakers. I'm subscribing to, 5 people, each of which is producing 3 bit rates. So I want 5 different ABR schemes happening at the same time, and I want each one of them to consume 1/5 of the total connectivity available. So in that case, we can simply add a new number here, which is the throughput fraction. And if you specify n, then you want the set to be evaluated as if it were assigned 1/n of the total available bandwidth. So I think this is a nice improvement. This default, if you don't specify it as 1, you want to take up the entire channel if that's the only thing you're switching on. But it does allow, with a relatively simple improvement, it allows a good feature base, which is multiple concurrent ABRs happening within your connection.
I would say there's some settlement on the Zulip to kill the timer, to kill the timeout part.
Okay, that's cool. That's feedback I'm looking for. Thank you. Can we get rid of DTS activation while we're killing things? And the argument here is that all I need to do is tell the relay when it's safe to start switching, right? Because if I'm in the middle of defining a switching set and objects arrive, it's going to start sending them. And those might not be the ones that I want. So we can get rid of DTS activation parameter by simply adding an activate switching flag to our assignment. And it's normally 0, which means, hey, I'm going to send you more things for the switching set. But on the very last time you call it, you would set it to 1. And that's the signal, OK, relay, you can start actively switching. So I think this is a much cleaner implementation. I like getting rid of parameters. And I would recommend we get rid of the DTS activation parameter and replace it with a little flag in our switching set assignment parameter. And can we extend this to a publisher-controlled scheme? It's actually very simple to do that. So in the scheme we've described today, the client is reading a catalog or it's got out-of-band information and it's setting up these thresholds itself. But the publisher could do this if I wanted a very simple client, right? So there we can define a track property. I think that's the new name now. And in it, it would supply the information shown here. What ID does this track belong to? What's the throughput threshold? What's the fraction? And then we add on one other number, which is the number of tracks in the set. And this is because the relay, again, needs to know when is it safe for me to start switching. And it's safe when you've got at least 3 tracks. You've got all the tracks in that have a common set ID, then you know you're ready to start switching. So this gives us a publisher-controlled scheme that works in a very simple, a highly congruent mechanism with the client-controlled scheme with the same behavior on the relay. So I really think we should do this as well.
Colin's in the queue.
Colin for Q.
Okay. So quick question on this one. I'm more concerned at the startup, you're not going to have accurate estimates. Do you have thoughts about how we get those initial estimates? Those seem like they'll be like, and what happens before the estimates of the available bandwidth are good? Because that seems like it's going to really influence the initial experience much more than when you turn these things on or off or how long it takes to set up these tracks. I mean, all these control messages are going to happen almost instantaneous. But I don't think you'll know what to do at that point. So what's the thoughts on the timing of when you start switching and how you deal with it before you have enough information?
Yep, that's a very good point, Colin. Startup is always the problem. We go over scarcity of information because we will have with the congestion controller some estimate of the throughput, but it's probably very application limited. We've done nothing but exchange some setup messages at that point. So we're going to probably have an estimate that's the low end of what our connection can truly support. So the one argument is, okay, go with the low end. You will initially start at your lowest bit rate, which is the safe way to start. It's perhaps not the best quality for the user, but it's safe. And as soon as you start sending data, you're going to have a higher estimate in your congestion controller, and you should switch up pretty rapidly, probably at the next group object. So that's one approach. The second approach, and there's a comment on this in the document, is the client can provide a default start solution. So it could say, at the beginning, I would like you to at least start at this 1 megabit stream, not the lowest one, not the highest one, but somewhere safe in the middle. This is analogous to HLS. It has a similar scheme. Dash can also do something like that. But it's a way for the client to say, if you don't have confidence in your throughput estimate, then take this default track. So we can also go down that route, and it's not exclusive with the first solution. A third solution the client can do, there's a separate thread coming in MOQ about padding tracks. And the client could basically ask for a padding track to be sent to give the rate controller better estimate of the throughput before it begins its subscription. So that would delay startup, but maybe it works it into the application. But the client has some control over this, so it might want to do that.
Well, we have 3 minutes left and 3 people in the queue, so can you just wrap
Okay,
it up
sorry,
really
long
quickly?
answer. There's a number of ones. Okay, next in queue.
Or do you want to take the queue or do you want to finish your, finish your slides?
I just have, yeah, this is, do we want to switch on something other than throughput? So it's possible that you might want a more complex algorithm that says, I want to take path and packet loss and history and other things into account, and maybe relays compete on how good they are at switching. So what we can do is just create an IANA table where you say, I have an algorithm for switching, and I'm calling it algorithm number 1. And you can register here. And then in my switching set assignment, I say, I want you to switch this, and I want you to use algorithm number 1. And it could go do some magic combination of observable properties and switch for you. So that's a suggestion. Maybe it's something we add down the pipe. I'll stop there for slides and take questions.
I'm going to close the queue soon, so enter it now if you want in.
Hello, this is Tony from Disney, and I have 2 questions for your page 6. Yes. From my understanding, this example. From my understanding, your proposal is to make the relay side track selection. But I would like to know why the subscribe need to figure out the bandwidth throughput number.
Because the relay doesn't know it. The objects flowing through the relay are opaque binary objects. There's nothing that the relay knows about. It doesn't know if this is 300 kilobits per second audio or 10 megabits per second video. So the client needs to tell it this information. In the publisher case, we create a property where the publisher does provide this information, okay? And then we don't need the client to specify it. But for the normal case, the client has no idea, sorry, the relay has no idea what the objects are or what size they are, and therefore the client needs to tell it and set the level that it wants to switch at.
And from my experience, I think the relay is responsible for the bandwidth observation and estimation. And the specific observation and estimation method is really different. So this kind of throughput of threshold maybe very limit the capacity of relay.
Okay, so your point is the relay is not going to be able to make a good estimate of the
Yes.
throughput?
Or will damage the performance of bandwidth estimation of relay. I'm not suggesting anything, just put out my curiosity. And the
we don't have enough time, so we're going to have to take this offline. Gerte.
Oh, okay.
I'm very happy to, I'll be here for the next half hour, so I'm happy to continue the conversation.
Hi, Gurtej from Apple. Could you go to slide number 11 for a second, please?
11.
Yes. So that's the publisher side. So here you suggest that set throughput fraction, right? And that's something that the publisher is going to say, but it does not know about like how many remote participants are in a conferencing call that like I am viewing as a subscriber. So how is it going to set that?
It's true it doesn't, right? However, this is usually done in an application context. I'm a web conferencing publisher and I'm publishing for web conferencing clients. So I know that there are going to be several of them, but it's a very good point. If my application knows that there will be 5 publishers, then it can add that throughput fraction. But it could well be that it's not generically available enough that we might want to remove it from this publisher control scheme.
Concretely in a conferencing call, like it also depends on like how many views you're actually viewing on your screen. And it might be like you are seeing, like if you're on a Mac, you might be seeing all 32 participants at a time. Whereas if you're on a small screen device, you're only seeing like 5 of them at a time. So, and that information is usually only available on the subscriber side.
And this is a weakness of any publisher-defined scheme. It cannot react to differences in the client. So it's only really useful where you have a very thin client that is highly deterministic, that never changes. If you've just got like one app on a mobile phone that does one thing, then publisher-defined is appropriate. But in almost all other situations, client-defined but server-implemented gives you a lot more flexibility and control.
Right, got to go offline. Alan.
Okay, I think this is like a good general like direction. I mean, there's a lot of good tech. We don't have time to do all the technical chat. I'd say like keep rolling with it. My question is like, what's the sort of disposition here? Are we going to like adopt this draft? Do we think it's like an extension that will go parallel to MOQ-T, or are we? I mean, is that our current plan?
I think so. It's so hard to hear here. I got like multiple echoes. So. Did you guys?
Are we going to do this as an extension?
Is this going to be an extension, or you want to get it in MOQ-T?
I want to get this in a MOQ-T. I think MOQ-T should have a simple ABR scheme from day one. We are media over QUIC as our primary use case, and we are a push-based system, and having some ability for the server to switch on the push, I think is a core behavior that we should look at getting in from day one.
Okay, I think going the route of it, maybe we need to adopt the draft and work through the issues, and then when it's ready, we can merge it in, because there's already a lot of issues with the draft, which I think are resolvable, but it's kind of on a parallel tracks right now.
Yeah, just briefly as chair. I mean, I think we'll continue to develop on the draft, and when we feel it's ready, we can make a decision whether it should be an extension or go into MOQ-T. Okay, to us, you get the
Hi,
last word.
so thank you. +1, this should be a core mock T, and again, how we get there is a different thing. And we'll this is a really good start. But this kind of going back to Gurtesh's point, this kind of misses out when you have multiple switching sweats, and how do we kind of make the decision based on that? And that can be something you can easily add to your draft. I'm happy to help you on that. Thanks for the work, though.
All right, thank you everyone for your comments. Once again, if you're a proponent, I strongly encourage you to look at the Zulip records because they were very productive. And we will see you all on Thursday. Thanks, Will.